Now, I've realized after listening to a few days of talks that perhaps symmetry is not central to your area of interest. Would I be right? I'm not right. You know all about it. You should have gone like that. So, I'm going to give you a little bit of softening up material so that when you read the article, you'll be able to follow it from the beginning, because when I looked at it last night, it really was a bit in your face if you were not really up with symmetries and algebras and associated stuff. Now, the whole thing is really concerned with transformations. To avoid the problem of dealing with products of things which get larger and larger, you start off with infinitesimal transformations. Now, I know this is a finite meeting, but if you add up enough infinitesimals, you eventually get something finite. So we start off with the infinitesimal, find out what we can, and then integrate to get the finite. Now, these transformations can be generated by differential operators. Now, these differential operators can come in various forms. The simple one I'm going to look at is called a point transformation. In other words, the functions involved in the basic definition, and let's just think of a simple case where you have, say, y double prime is some function of x and y. Now, I emphasize that I'm just taking a simple case. It could be any order, it could be any number of variables, it could be ordinary or it could be partial. It certainly doesn't have to be linear. In fact, the whole attraction is the success that you can have with equations which are nonlinear. So you look at a differential operator, in this case, and we'll just take psi x as a point. That's just to emphasize that they're dealing only with x and y. In other words, the dependent and independent variable. You could have, of course, derivatives in that function. You could have integrals in those functions. If you've got derivatives, then you have contact transformations. If you have integrals, then you have integral transformations. So, of course, obviously, it's more complicated. And I'm trying to keep this simple, so that at least I can understand it. So, the problem you may have wondered about, now, we've got a derivative with respect to x, a derivative with respect to y. What's going to happen to the derivatives? We don't have to worry about integrals in this case because it's a differential equation. We have to look at the implications of the definition of the psi and eta to get the extensions. So it's just given by that. Now, if you have the second extension, it's just going to be gamma 1 plus and if you keep going to higher derivatives, obviously it's going to become more complicated. That's why I'm not going to go to higher derivatives. Now, you look at, well, let's not have such a complicated equation. We'll take the example fairly straightforward equation. You can solve it quite easily, but we're interested in doing it the hard way. So if you apply the operator, gamma 2, right, so the e to double prime and that's just going to be plain eta. All right. What do you do next? No comment was a stern reply. Any suggestions?
Apply it again.
Sorry?
Apply gamma 2 again.
I still can't hear you. You should.
Apply gamma 2 again.
Oh dear. That would be terrible. It was bad enough applying it once. No, I'm sorry. Particularly to the ladies. No, you just expand it, so let's see now. Psi prime, I can do that. What are we using? F? No, we're not. Okay. Oh, okay. Exactly. That doesn't look right, actually. Oh, yes, it is. Right, there's enough. I think I've left a couple of terms out. Now, I must point out to you, these calculations are actually tedious. And when we started doing this a bit out of over 45 years ago, I was rather lucky that there was a chap at the CSIR in Melbourne. Do you have a CSIR here?
Yes.
You do? Okay. So it's the same sort of organisation, I guess. he wrote a program. His name was Alan Head. And he wrote it in a rather interesting language. Have you ever heard of MuMath? Yes, well, you're showing your...
Did you say MuPad?
Sorry?
What did you say?
MuMath.
No. I thought you said MuPad.
No, MuMath. You heard of it? Yes, well, maybe I'm showing my age a bit. And the problem with it is there wasn't a carrier for it. But then along came a friend of mine, a Greek chap by the name of Stelios Demas, and he wrote a lovely program called Sim. And it was based on, what's that one we use all the time? Oh, hell.
Python? C.
No, I'm talking about 40 years ago.
C. Fortran. Fortran.
No, it was a symbolic one. What was a symbolic one back those days?
Pascal.
Who? Yeah, I didn't hear you.
Pascal. Pascal.
No, it wasn't Pascal. It was in, I can't even remember what the language is. Sorry. Anyway, it was a lot easier to use. And now if you buy or get hold of a copy of Mathematica, you'll find in one of the applications they have a symmetry package. I haven't used it, but I only found out about it recently. And these days I don't calculate many symmetries. I like to employ young people to do it. It keeps them off the streets. Well, I hope it does anyway. So, if you have this and you apply it to, that one, you're going to have, that's incomplete, I'm sure. Anyway, you have gamma 2 on y double prime. It's going to be gamma on y. And you go through the hoops, and what happens? You end up with a result. And in this particular case, you find that gamma has an 8-parameter solution. Right. That means you have 8 individual operators. Gamma 1, gamma 2, etc. Now you can actually take these in any combination you like. You don't have to just say, well, I've got C1 there, so it's that, C2 there, that. You may maybe want to take C1 plus C2 and C1 minus C2, or any variation. What you do look for is the operators which look simple. Now, what do you think would be a simple-looking operator for this particular equation? One which leaves it invariant. Oh, I thought you knew. Let's try, say, x. Y double prime equals y is invariant under translations in x. That's what x means. So, having said that, what can you do about it? I mean, all right. We should pause for a moment and say, why on earth bother calculating these operators, these symmetries, apart from giving you a good chance to have a sleep? Well, no suggestions. If you have a differential, well, maybe people don't do with differential equations. Surely you do. Yes, sometimes. What do you try to do with them? Right, you try to solve them. Right? You try to solve them, and there are various ways and means of solving differential equations. Over the centuries, these methods have developed. I mean, and if you cast back your minds to your undergraduate years, you'll remember being tortured by it, I imagine. And one of the advantages of calculating symmetries is to determine the simplifications and eventually the solutions. Now, for example, if you look at that equation, is there anything simple you can say about it? I'm not talking about the answer. You know the answer. We're not talking about that. You've got y double prime is y. If you multiply it by y prime, you've got y prime, y double prime, y prime, y. So you can integrate that. And so you've made some progress. You've gone from a second order equation to a first order equation. Can you go any further? Oh dear. You just want to make me work, that's all it is, I know. This is. So you can take that one, sorry, you've got y prime squared is 2i minus y squared, so that dy is square root of, so you can integrate. Sorry, someone said?
Y prime square minus y square.
Sorry, I can't.
It's a plus.
Sign. It should have a plus sign.
Is 2i plus.
2i plus y square.
Oh,
And you have 2 minutes.
2.
Yes.
Where? I've got a 2 there.
You have 2 minutes. Sorry.
Also, there's two solutions, right? There's plus or minus for the square root.
Oh, all right. So you help giving me back a minus. Well, we all know how to integrate that, don't we? Well, when I say we all, of course, I'm not using the royal plural. I'm not talking about myself. I'm waiting to hear suggestions. You're not suggesting. All right, so this should give us plus or minus x plus a constant is equal to, must be about arc sine y over root 2i. Okay. Now, yes, all right. Problem is, we've got two solutions. And since my time is up, I leave it to you as a midnight exercise to work out how to resolve the question of whether it's plus or minus. Thank you.
Thank you very much.